Hello everyone, welcome back. We are going to be talking about graphing the function f of x equals cosine x today. It's a lot like graphing f of x equals sine x, but it's got some differences and some similarities, and we'll look at those today. All right, I'm going to graph cosine x. I'm going to start at 0. Remember, I'm thinking about this unit circle, and I'm talking about the x values here. So when x is 0. In other words, when I plug 0 into the function, the cosine at 0 is 1. At pi over 2, that's the point 0, comma 1, the cosine at pi over 2 is 0. The cosine at pi, well, the x value at pi is negative 1. At 3 pi over 2, the cosine is 0, and then back at 2 pi, the cosine is 1. So what I'm looking at here is, let's put in our radian measures along the x-axis, pi over 2, pi, 3 pi over 2, and 2 pi, and then negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. All right, so it starts at 1, goes through pi over 2, 0, goes down to pi negative 1, goes through 3 pi over 2, 0, and finishes up its full period at 2 pi, comma 1. And so what we're looking at here is this nice, what should be, smooth curve of the cosine function. You may have guessed, and you're correct if you did, that the remaining part of this cosine function, where the x values are negative, is a repeat of what we see here. It's just a mirror image over the a reflection over the y-axis. And so our values are 0, negative 1, 0, and 1. And so the cosine curve starts high. Oops, where am I going? Starts high. This is why it's good to plot the points first. Cosine curve starts high and ends high. Right? It's a bunch of little peaks and valleys. All right. And you may be thinking, oh, it looks a lot like the sine curve. You're right. They're just a shift of each other. But I want you to be looking from the y-intercept, what's it doing, and then we'll go from there. But for now, know that the y-intercept is 1, goes down to a minimum of negative 1, and ends up back at 1, where 2 pi is. All right, so now some facts here that you need to know about the cosine function. The domain for the cosine function is the set of all real numbers. As you may have guessed, you can just keep going around and around that unit circle, and you can find the value of cosine for any angle measure. The range is from negative 1 to 1 included, and cosine is an even function, which means that it's symmetric with respect to the y-axis. The cosine function is periodic, and its period is 2 pi. Periodic means it just keeps repeating itself in that cycle over and over again. The x-intercepts for this function, we'll scroll, are, let's see, negative 3 pi over 2, pi over 2, pi over 2, and 3 pi over 2. So negative 3 pi over 2, negative pi over 2, positive pi over 2, and positive 3 pi over 2. There's that even aspect that you see that with respect to the y-axis, this function is symmetric, with respect to the y-axis. And the y-intercept here is at the point 0, comma 1. The maximum value is 1, and it occurs when x equals 0 and when x equals 2 pi. And the minimum value is negative 1, and it occurs where x equals, let's look at that, negative pi and positive pi. Okay, here are the basics for graphing the cosine function. Next, what we'll end up talking about, and what I'm asking you to do for homework, is to apply the basic parent function, sine and cosine, take those parent functions, and then apply some transformations. Apply a shift of up 1 or down 1. So let's look at a couple of those now in the next video.